All right, so welcome to our 1 p.m. lecture. We'll keep this short and sweet because I know nobody wants to be here. We got people falling asleep before we even started, so that's a great sign. So, and some of this is going to, actually a lot of this is going to be a review from our D1 year that we spent together in dental materials. So then it probably didn't make any sense to you because there was no clinical context. Now we at least have prep crowns and seen some Emax crowns, and you've played with some composite in your operative class. So hopefully some of this concepts and ideas will be a little bit more relevant and allow you to remember it a little bit more easily, right? So we're going to start with this idea of cementing a crown. And last year we had talked about there's two different ways, two different categories that we're going to put these cements in, or sort of two different ideas for cementation. We're not going to spend a ton of time on this luting idea because we're going to get into it when we cement or lute our gold crown. But the idea there is we just want to fill the space between the prep and the internal surface of the crown, which in that case would be some sort of metal. So whether it's a PFM with metal coping or a full casted crown, you got a metal to cement interface. So the cement that we use, there's no actual bond of the cement to metal. It's just relying on sort of mechanical interlocking or friction, okay? But the advantage of that is, of course, if you ever need to cut it off, all you have to do is break the seal, and then you should be able to remove the crown. So we'll be able to do, we're going to do this exercise when we cement the crowns when we meet back in October. We're actually going to cement your pretty gold crown that you shined up, and then we're going to promptly cut it in half. Okay? So that's luting, and the luting cement that we use in our clinic, just for your reference, is resin-modified glass ionomer, specifically Fuji Sem 2 is a product that we've been using over the years, right? But let's get into this idea of adhesively bonding a crown into place. And this works well, or this works when you have a all-ceramic material that has a glossy phase to it, which Emax does. So let's review our materials a little bit. Zirconia, what do we know about zirconia? It's strong, it's hard, because it's got a well-ordered crystalline structure. So there's very little glassy phase to it, which doesn't allow for good bonding. Okay? So with zirconia and with metal, kind of internal metal crowns, meaning cast or PFM, or full metal or PFM, you're going to lute them, okay? Because there's not much that the cement can stick to. Now, with Emax and Empress, you have more of a glassy phase to it. And what you also learn in your Operative 2 class when we jump to veneers, and we use traditional feldspathic porcelain, that of course also has a glassy phase to it, because that's our feldspathic porcelain. Okay? So all these things that you have a kind of silica-based or glassy phase, you can get some sort of bond to it via the cement. All right? So we have adhesive cement or resin cement. So different companies will, there's different terminologies used. I know it gets confusing because we talk about cementation, then there's like luting versus bonding. So for the purposes of this class, we're going to say adhesive cement or resin cement. Those will be used kind of synonymously, okay? So they kind of mean the same thing, meaning that we're going to treat the tooth by etching to create these little micro tags, macro tags in either the enamel or dentin, okay? And of course, dentin, we have that hybrid layer, right? All right, so let's talk about the steps for adhesively bonding the crown. So if we moved from left to right, we know that we have etched enamel, or it could be dentin. And with that, the purpose of etching was to, to roughen up the surface so we increase the surface area so that we can get better kind of penetration or interlocking with our bonding agent, right? So once you etch the enamel, you're going to have this bonding agent, and then the layer in between is going to be your resin cement, and then your resin cement will connect to your crown in some fashion. Okay, so let's start with the left side. So etched enamel, and then you're going to put your bonding agent on. So let's talk a little bit about the difference between enamel and dentin. So when we bond to enamel, do we want that surface completely dry or a little bit wet? And why do we want it completely dry? Yeah, Jen, you had an idea?
Hydrophobic.
Phobic, okay. What is hydrophobic? The bonding agent, right. So bonding agent will do better when it's in a completely dry environment because it's hydrophobic, right? It doesn't like water. And we don't have to worry about over drying the enamel because it doesn't have this collagen bed. It's mostly inorganic material, right? So you don't have that collapse of that collagen bed. Whereas if you contrast that with dentin, we know that we want to keep that just a little bit moist so we can keep that collagen bed intact and doesn't collapse. Okay, so that's a distinction. And yeah, so depending on where so your class 2 composites, you know, most of it is in dentin. So that's why we tell you, okay, we're going to have you keep that slightly moist, and knowing that we're going to have a little bit of a compromise in the parts that's touching the enamel. But most of that prep that you have exposed is in dentin, so we want to maximize that dentin bonding. Okay? All right, so we know our resin cement, that is an organic material, and our tooth is inorganic. But because that bonding agent penetrates into those micro tags or macro tags very well, you get a really strong bond to that. So our adhesive will connect and make a chemical bond with the resin cement because they have the same, it's basically the same makeup. They're both bis GMA base material, right? So your OptiBond Solo Plus, that's bis GMA base, and then your resin cement has some bis GMA-like chemical too. So those things will be able to bond or hook up with each other. Okay? All right, so that's that. So we know feldspathic porcelain. So I use this slide just as a generic kind of, you know, each kind of ceramic, there's differing compositions, but the kind of underlying principle is that you have some sort of crystalline phase and some sort of glassy phase. So in the case of Emax, you know, it's a lithium disilicate base rather than a lucite, but still the principle applies that we're trying to bond to this glassy phase that's made up of silica. Okay? So the question is, well, how do we get the silica to bind and kind of adequately bond to our resin cement? So again, we have a incompatibility in materials in the sense that one is organic, the other is inorganic. So we use this thing called a silane coupling agent that has two tails, or two ends to this chain. One side is organic, the other side is inorganic. So the organic side is going to bond with the resin, which is bis GMA base, and the inorganic part is going to interface with the glassy phase, or the silica that's in our crown. Okay? So we need to add this silane coupling agent. And specifically, we're going to use a Ivoclar product called Monobond Plus. Okay? So that's our silane coupler. You can think that that connects the inorganic to the organic, or the resin cement to the crown. So you got to have some sort of coupling agent that brings those two pieces together. So that's that idea. All right? Any questions about that so far? So we have etched enamel. So if you think through the layers, you have etched enamel or dentin. You're going to have our bonding agent, and then our resin cement, and then the silane coupler that will connect the resin cement to the crown. Okay? So hopefully that's pretty straightforward. So again, think about all these steps we got, right? A lot more technique sensitive than just luting it. So what are the steps in luting? Fill the crown with cement and just slam it home, right? This one you got to etch, you got to rinse, you got to scrub, then you got to light cure, then you got to, right? Then you got to all this other stuff. Okay? All right. So a little bit about adhesive cements. We're not going to get too much into the details of all of them because there's many different types. But I just want to highlight the fact that there's companies will manufacture cements with varying kind of properties to them. And one is they can vary the method in which it's cured. So some are light cured only. So those are going to be beneficial, or those are used in areas where the crown or the veneer mostly is thin enough where light can penetrate through. Okay, so you don't want to use a light cure only cement, resin cement, in situations that the crown is maybe a little thicker or more opaque where light can't penetrate. Then you have dual cure options that have both a chemical and light activation. Okay, so you can cure it one of two ways, right? So remember we talked about our methacrylates, and those we have 3 different ways to activate those: light, chemical, and heat. So very similar kind of principle. So what's our activator for our light cured products? Right, we have camphorquinone is that a molecule that starts that process. So each cement, when it's light cured, will have a compound similar to that absorbs light and then starts this polymerization process through free radicals. Okay. The other way is through some sort of chemical, or tertiary amine is sort of the most common compound that is used to break up the benzyl peroxide, right, to start the free radical formation and thus polymerization reaction. Okay. So they'll formulate differing cements with these different things to achieve these properties. Okay, because there's some advantage to light cure and some advantage to dual cure, right? So let's just think about that. So your dual cure is advantageous when you can't get light to penetrate through. So in that case of that thick crown, well, you want something that chemically starts that process. But maybe you don't want to wait all that time to clean up your margins. So think about when you first slam that crown home, right? Instead of waiting 5 minutes before it gets to that set stage, what if you can just cure the parts that expose real quickly? That'll harden a bit, and then you can clean off that excess cement. So that's a pretty typical procedure, and that's what we're going to teach you guys today, is we're going to tack cures. One word that describes it is a 1 to 2 second cure on the buccal and lingual surfaces to get that cement to initially set around the margins. Then it gets to that sort of doughy kind of consistency that's very easy to clean off. Otherwise, you're waiting much longer for it to reach that consistency. And yeah, so you save some time there. Okay? So those are the different curing options, and there's different etching options. So this is why I wanted to go back to your D1 course where we talked about differing generations of bonding systems. When we talk about fourth, so what's OptiBond Solo Plus? What generation is that? Oh, it's right there, right? 5th. Okay. All right, so we're going to go through, I think I have a chart here. Right, 4th, each one is separate. The etch, prime, and adhesive are all in separate bottles. Okay. 5th generation, we have the prime and adhesive. So let's maybe revisit this. This won't be on your test, but it's something you should know. Remember the reason for adding a priming agent or a primer? Mackenzie, you nod your head? What was that? Okay, give it to us.
Isn't that just to combine? Just kidding, I don't remember.
Okay, yeah, you're so confident. Sorry. Maybe the moment got to you. Okay, well, if you didn't hear Mackenzie, what she was saying was that the priming agent, or the primer, is designed so it penetrates down into the dentinal tubules, right? Because that tubules are it's water containing, right? And remember we said our bonding agent is hydrophobic? While the primer changes the environment from a hydrophilic environment to hydrophobic so that the bonding agent has a friendlier environment to bond to, right? So that's, yep. So Mackenzie had that. So thanks for that tip. If you weren't so confident, I wouldn't have called that. All right, so that's the primer, okay? So OptiBond, the primer and adhesive were in the same bottle, basically. 4th generation, they're separate bottles. 6th generation, sometimes you have the etch part and the prime part in the same container. And then the 7th generation, you have it all in kind of one thing, okay? Well, you can take this concept and you can apply it to cements, right? So the idea between 4th and 7th generation. 4th generation, we can consider that sort of our gold standard, meaning our bond strengths are best, right? But think about all the steps you got to do. So that's more technique sensitive. On the other end of the spectrum, when everything is in one bottle, there's just one step, but our bond strength is not as good, okay? So anyways, that's how you want to think about, as you combine steps, yes, it's more convenient, right? It takes out some of the technique sensitivity out of it, but what we found is that the bond strengths aren't as good, right? So let's jump back into that slide when it talks about cements, and we can also see that there's differing ways in which they formulate these things. So when we say total etch, think of this as very similar to or essentially the same steps that you did when you bonded to your composites, right? You etch the thing, you start around the enamel, then you go in the dentin, then you rinse that off, and then you scrub your OptiBond, blow it thin, light cure, and then you stack on composite, okay? So same steps with your total etch system with these cements. Self-etch is when, like that 6th generation, where the etch and the prime or the bond is all in one kind of system, where the bonding agent or adhesive/primer contains the etch in it. The selective etch is when you start and just selectively etch the enamel first, rinse that off, and then you follow your regular protocol with the self-etch, okay? And then the self-adhesive is very similar to the 7th generation bonding system where everything is all in one container, okay? So, I don't think, I may ask one question about this. It's kind of confusing, so it won't be like a hard question, okay? So that's that slide. But the principle is there's formulated different ways for curing method plus the etching the etching steps involved, okay? And again, as you take out steps, it makes it less technique sensitive, easier for the practitioner to use, but you're going to compromise some material properties. All right, so in this process of cementation, one of the things that we want to talk about is this step here. Let's see if we put it in. Okay. Let's go and actually do the first two steps here. Make sure the inside of the Emax crown is etched with hydrofluoric acid. So here, before we do paint the silane layer on, so here we have our crown. So let's go. These are all our steps, right? So before we add the silane to the crown, remember the silane helps form that bridge between the crown and the cement. We want to clean the inside of the crown off, okay? Because what happens is when you try that crown in the mouth, you have some of the phospholipids in your saliva that kind of adhere to the inside of your crown, okay? By scrubbing that crown with Ivo Clean, which is this product here made by, once again, Ivo Clar. So this pink bottle here, this removes any phospholipids that may bind to the internal surface of the ceramic. Okay, so basically just think of it as it cleans off the inside of it. Okay, and even prior to trying the things in the mouth, when it leaves the lab, what the lab generally does for you is they'll add hydrofluoric acid to the inside of the crown. And the reason for that is very similar to the enamel where we've etched it to roughen the surface. That's essentially what you're doing with the crown as well. So you're using a different type of acid, though. It's a hydrofluoric acid to roughen the inside surface of the crown so that more of that silane coupler and resin cement can engage that crystalline structure. Okay? So any questions about that? So hydrofluoric acid is used to etch the inside of the crown, and the purpose of that is to roughen the surface, to increase surface area. Right? That usually is done by the lab. You can do it yourself too if you don't trust them. Then after you've tried the crown in the mouth, some of that phospholipids get adhered to it. So you want to clean that off with Ivo Clean before that crown actually gets bonded onto the tooth. No, I only got 2 nods. You're talking about the internal surface of the, yeah. So usually what happens is it comes etched already, and then you can try it in the mouth. So all you have to do is clean it with Ivo Clean. Yeah. But if they don't etch, so that's an important thing. When we talk about lab communication and what to look for in a good lab, so one of the things you want to ask is when they make your all-ceramic crowns, oh, what do you guys etch with, right? And then if they give you an answer, it's okay, they know what they're talking about. Okay, they're like, oh, etch, what's that? And they're like, oh, okay, maybe I got to etch it myself. Okay. All right. So yeah, that's a good point. So if it comes etched, then you don't have to re-etch it. You can just clean the inside. Yeah. Yes. Uh-huh. Yeah. So zirconia is it does best with zirconia, meaning the phospholipids bind to that real easily. So yeah, the Ivo Clean will enhance the bonding of that to zirconia more than if you were to compare it to something like Emax. But it does have a benefit with cleaning Emax as well, just relative to another material. If you're to compare the two materials, not as much, but it still helps. Okay, good point. Yeah. Anybody else? So we clean it off, and let's go through our steps. So we've prepared the crown by etching the internal surface. We've cleaned the inside with Ivo Clean, so 20 seconds, and then we rinse. So that removes the phospholipids. And then we're going to scrub our Monobond Plus, which is our silane coupler, again made by Ivoclar, and let that sit for 60 seconds. And then we're going to air thin that to evaporate it. Okay? Then you can switch over to the tooth. You're going to isolate the tooth. You're going to etch, prime, bond, just like you would composites. The only difference I think we're going to have you guys do is we're not going to have you cure the bonding agent. What we found is sometimes we don't air thin that bonding agent quite enough, so it actually pools. So you have a really thick area of your bond pooling in a certain area. Then when you take your crown and try to seat it, sometimes it didn't go down all the way because you've created a thick layer in one region. Okay, so we're a little bit cautious about you guys curing. I know a lot of the directions say to cure, but we've run into a few problems in the past where students weren't careful in thinning that out a bit. Okay, so we'll leave that uncured for the purposes of our clinic. Does that make sense? So anyways, yeah, we switch to the tooth. You're going to isolate, etch, do all that, and then load the crown with cement. You'll seat the crown, and then we're going to tack cure on both sides. So we'll get to a kind of rubbery state of that cement rather quickly that you can very easily clean off. And we'll show you a video of that coming up. Okay? All right, so let's finish things up here. So apply dual cure resin. Yep. So tack cure for 2 seconds, and then clean the outside, and then you'll finish off with a final cure. All right, the last thing I want to talk about is, so there's always a little bit of a gap, right, at your margin, or a layer of cement. Usually like microns, like 50 microns maybe. But the idea there is the last layer of that composite, or resin, or anything resin-based, we have this oxygen inhibitor layer that we've talked about over and over again. So that top layer doesn't get fully polymerized because the air is obstructing that polymerization reaction. So what we do is we put glycerin, or specifically the brand or the thing we're going to put is called liquid strip, and we're going to put that over the margin so that air isn't in contact with that layer, and then we're going to cure that again so that that oxygen inhibitor layer becomes fully polymerized. Okay, so just an extra step to ensure that the outermost layer of that cement comes to its full polymerization. It's fully polymerized. Okay, so that's that step. So let's finish up with when it comes to Emacs, we have the option to either lute or bond. And we've reviewed this before. But the idea is luting is sort of the simplest way to attach a crown to a tooth. And the advantages of that are its technique, the technique is very simple. And if you ever need to cut it off, it's easy to take off the crown because all you have to do is break the seal. Okay? So most of the time, it's almost preferable to just lute. And then the couple of situations where bonding becomes very advantageous is when you don't have enough retention or resistance form. So the question is, well, what situation should an all-ceramic crown, more specifically Emacs, should be adhesively bonded? Well, when you have minimal crown thickness or insufficient retention resistance form. So let's go through this. Okay? So we know retention is the ability to withdraw that crown along parallel to the path of insertion, and resistance is sort of a tipping force, right? So if the tooth itself has tall enough walls and they're tapered in such a way that it'll resist that movement, you don't need the extra help of that cement, or you can think of it as glue, to hold that crown in place, because the prep itself naturally does that. But if you have an over-tapered restoration, let's say, or a very short crown, and you don't have the natural resistance form to resist any dislodging forces, then you would want a cement that's going to help you hold that crown onto that tooth a bit better. So that's where an adhesive cement is very helpful. So when you lack retention or resistance form, an adhesive cement is going to be of much benefit. Where if you contrast that to a prep that already has sufficient retention resistance form, well, yeah, you can say the cement is stronger, but you didn't really need that strength to begin with because your prep naturally had that ability to withstand dislodging forces. Okay. The other thing that we want to highlight is if you violate that minimum thickness, or that recommended thickness, then we run the risk that that ceramic is going to fracture. Okay? So if you're worried about ceramic fracturing due to thinness, then you'd rather use a cement that's more rigid, because a more rigid cement is going to support that porcelain or that ceramic much better. Okay? So let's look at this chart. So on the aqua colored, those are the fracture loads of Emacs when it's cemented versus, or when you say cemented, think luting into place. And then the middle two columns there are with a resin cement. Okay, so you can see the fracture load is much higher when things have been adhesively bonded in place with a resin cement. Okay. So and then it's also further separated by the thickness of the material there. So obviously the thicker the material, the better it's able to withstand any fracturing of the fracture load. Okay? So when you get to a minimal thickness, or you're worried about and you want to strengthen or enhance the ceramic in terms of strength, then an adhesive cement is going to increase the fracture load better than if you just cemented it in place or luted in place with a luting agent. All right, any questions about that? So let's go through the steps of what you guys are going to do. So the first step that the lab does, and we'll just show you here, is to etch this crown with hydrofluoric acid. Instead of real hydrofluoric acid, we're going to give you just ethanol, okay? Because apparently they don't trust you with hydrofluoric acid because it's pretty toxic, okay? Ethanol is a little safer. You guys are used to ethanol, right? It's in all your liquors and beer, yeah. All right, so that's etched and rinsed out thoroughly. This is Ivo Clean. Remember, what's the purpose of Ivo Clean? To clean, good. Clean what? The phospholipids from saliva that adhere to the internal part of your, yeah, that'd probably be a test question somewhere. Yeah. Phospholipids. All right. So what do we say? 20 seconds and rinse, right? Okay. And then what's this? Silane coupling. Who's it made by? Aviclara. Thank you. All right. How long do we let this sit for? 60 seconds. Yeah. So you're going to rub this on the inside of it and then let it sit for 60 seconds. And the purpose of this is to connect the crown to the resin cement. Okay. All right, now we go to the tooth. It's helpful to place Teflon tape so that when you etch, you're only etching the tooth of interest. Okay. So that helps to isolate the tooth. And what's the next step after that? You're going to etch, right? So when we talk about in your operative class, we talk about if you're etching enamel, how long should you etch it for? 20 seconds. If you're in dentin, 10, right? So if you've prepped a crown, you're probably in dentin. So you don't want to over etch. What happens if you over etch? Yeah, you may damage the collagen bed, so rinse that out. And ideally, you keep that somewhat moist. And then we're going to layer on our bonding agent. So in our clinic, we have OptiBond Solo Plus. And then you air thin that. The instructions tell you to light cure, but we're afraid you guys won't thin it out enough, so we tell you not to. Yeah, I guess in sim we can trust you to do that. It's not a big deal. So I don't really care what you do, if you light cure or not, but all right. Then it's right. So think about all the layers we got. This is etched with hydrofluoric acid. It had been ivocleaned and silane placed. On the tooth, you had it etched, and then you have bonding agent. And now the last piece of the puzzle is your resin cement. So you fill that resin cement in, and then you seed it. Very similar to how you seeded your provisional. It's always good to bleed a little bit of that cement in that auto mix tip. Just so that first thing that comes out of that tip isn't always well mixed. Okay? So don't forget to bleed. So you can see at this stage, it's not, it'll smear everywhere if you try to clean it up. So you do a tack cure, buccal and lingual, and you'll see with my Explorer, it'll be in this sort of rubbery stage that is very easy to clean off. You see how it just cleaves off like that? And that's what you want to see. Okay. And then what do we know about this layer of cement right at that junction? It's not fully polymerized because of the oxygen inhibition. Right? So before we put the glycerin on, you want to tie a knot in a piece of floss and floss to the contacts, and then use that knotted floss to clean off any of the cement that's wedged in the embrasure space. Okay? So a knotted piece of floss. And then you want to be careful if you're going to floss up, always have somebody holding the crown down because you don't want that thing to dislodge. Or you can just pull the floss straight through the embrasure. Okay? Just like that. All right, so don't pop off any crowns with your floss. All right, so what's this? Glycerin or liquid strip, and then you can do a final cure there so that it's not inhibited by oxygen. Okay? Any questions about our process?